Hello. Today I'm going to walk through how DeltaStream works with OCI Streaming for Kafka to build real-time pipelines without any operational overhead. A lot of Oracle users already have event-driven systems in place. They track customer activity, device telemetry, financial events, or internal operational data. OCI Streaming for Kafka is a great home for that traffic. It is scalable, reliable, and easy to integrate with. But once the events land in Kafka, the real question becomes, how do we shape this data, filter it, join it, and publish something meaningful downstream without standing up large streaming clusters? This is exactly where DeltaStream fits. So let me set the stage for the demo. Raw topics are valuable, but they're rarely ready for analytics or applications. Most teams spend time building and maintaining Flink clusters or connector infrastructure to get from raw events to something that drives business value. DeltaStream removes that entire layer. With DeltaStream and OCI Streaming for Kafka, you can connect to your sources fast, explore data in a table-like way, write SQL to transform it, and then publish those results back to Kafka, all without owning the streaming compute layer. So let me show you what this looks like. First, let's use KCat to see what topics I have available in my Kafka cluster. It looks like I have a page views topic. So the first thing that I'm going to do in DeltaStream is to add a new data store, basically telling DeltaStream how to talk to the OCI Streaming for Kafka. OCI's streaming service exposes a Kafka-compatible API, so this is a standard Kafka connection. I can give it a name, and I can use that bootstrap server that I was using earlier in my KCat command. I'll choose my security method, and in my case, I'm going to be using username and password. DeltaStream also supports schema registries and TLS, so in case you need more secure authentication or schema evolution, DeltaStream can support that as well. I'll go ahead and add that data store. And once I save that, DeltaStream will reach into my OCI cluster and pull back a list of all the topics. I can select this page views topic and preview the data. I can see it in a JSON or table format, and this helps confirm the event shape before I write any transformations. So let's move on to the workspace. The workspace is designed to feel natural for people who use databases. You can treat streams like tables, but everything is live and updates continuously. Down at the bottom, we see all the data stores that we have defined, including that new one. From here, I can also look at my page views topic, look at the details, and create streams directly from this view. Otherwise, I'll want to define the schema for that page views topic. I can do that manually by using a SQL command that identifies the column names and their data types, which store I want to use, the topic within that store, and what the value format looks like. I'll go ahead and click Run, and I'll see that I now have a page views stream available for use. I can then treat this just like I would any other database. I can do a simple select star to preview the data. When I run a simple select star, DeltaStream will spin up a compute sandbox. It starts reading from the topic and streams the results to my screen. As new events arrive in OCI, you will see them appear here. So let's refine this. Now I only want to see purchase events, so I can add a where clause. DeltaStream supports Flink SQL, so you can do pretty much any joining, aggregations, filtering, or windowing operations that is supported by Flink. These types of queries are called interactive queries, and it lets me explore the data within my topic in a very natural SQL way. So notice that I just have the new purchases as they come into my Kafka topic. So there we go. We have a live filter view that updates as purchases come through. This is the kind of data you might want to alert on, drive recommendations with, or feed into downstream apps. And having a filtered view is great, but most real-time systems want a transformed stream delivered back into Kafka as a first-class topic. We can do that with a single command. Here is the SQL. I'm going to create a new stream, give it a new store name, or give it the store name, a new Kafka name that I want it to write to, and then the query that I want to use. What happens now is when DeltaStream runs this, it starts up a managed Flink job. It reads the page views topic, applies the SQL logic, and writes the results to a new Kafka topic called page view purchases inside my OCI cluster. I can monitor the job right here in the UI. I can see throughput, latency, input and output volume as the query begins to execute. I can send these metrics to my existing monitoring system through DeltaStream's Prometheus-compatible API. If I jump back into my terminal and run a quick KCAT again, I'll see that new topic is now available and data is already flowing in. Before I wrap up, I want to highlight one important point. Even though I'm showing this with OCI Streaming for Kafka, DeltaStream connects to many systems, not just Kafka. You can pull in CDC streams from relational databases, messages from legacy queues, files from cloud storage, or events from other streaming systems. And you can enjoin them, enrich them, or publish them back to the Kafka using the exact same SQL pattern. You can also write back to other databases like Databricks, Iceberg, and Snowflake. This is powerful for migrations or hybrid architectures. For example, you could blend OLTP change streams with Kafka activity in real time, or populate a data lake with curated events, or move from an older system into OCI with continuous replication and no service interruptions. So this is the full workflow. OCI Streaming for Kafka gives you a strong base for your event data. DeltaStream adds a simple SQL-driven way to turn those events into clean, actionable real-time streams that feed analytics, applications, and downstream services. The best part is that you do not need to manage Flink clusters or operational plumbing. DeltaStream handles all of that so your teams can focus on delivering value and not running infrastructure.